So I'm going to start recording. Okay. So about less than a week for your final project to be turned in. All right. So a couple things to just kind of reiterate about the final project. First off, if you don't have your so let's say it gets to Monday and it's 6 p.m. and you don't have your final project done, and you certainly don't think what you're going to get it done by, everything done by midnight, but you do have something. What do? You submit it anyway. You turn in what you have, right? And then in your video, you might want to go into what your expanded vision was and what blocked you from getting there. But you turn in what you have, especially if what you have is like a partially working thing or a partially working demo. If it doesn't have, if it has features X, Y, and Z, but not A and B, then go into that. That's okay. It's meant to be a learning experience, and part of the learning process is learning how to evaluate how difficult things are. In computer science, it is notoriously hard to figure out, to get a good idea of what is difficult and what is not. KCD, difficult. Let's see. This explains it kind of well. Difficulty programming. Let's see if this is come on. You can do it, Google. I have faith in you, Google. Yeah, there we go, tasks. Oh, okay, so this is from the explain XKD. So when a user takes a photo, the app should check whether or not they're in a national park. Sure, easy GIS lookup. Give me a few hours. And check whether the photo is of a bird. I'll need a research team in 5 years. In computer science, it can be hard to explain the difference between the easy and the virtually impossible. You're just getting into computer science, just getting your toes wet, so you have no idea what you're still in that phase of what's easy and what's difficult. But even the things that are difficult are things you can at least make some attempt at, right? Which is great. So once again, right? Generally speaking, if you've made it this far and you're turning in and if you're turning in a mess of code and it looks like you bit off more than you chew and it was just an absolute disaster, you're probably no worse than a C, okay? No worse than a 70 for an absolute disaster as long as you tried. If you tried and it wasn't a complete disaster, but you didn't get done. But you didn't get fully done, that's where we're looking at the BA territory, okay? Absolute disaster is a C here, okay? So that should hopefully take some stress off, okay? If it showed that you tried, then great. But that's the main thing. We don't really give extensions for the final project. The only reason you would get an extension for the final project would be because it would be of the same kind of reason you would need an incomplete in this class, like a medical emergency, circumstances beyond your control preventing you from completing the course. That's the kind of stuff where you would get an extension for the final project. Penalty-wise, okay? Again, late penalty is the same as on exams, 1/10 of a point per minute late. So it does actually kind of matter here. Turn it in. Again, what we're expecting is kind of a YouTube video. Now, a video uploaded to YouTube or somewhere else. I highly recommend taking a look at OBS and seeing how that works. This is used by basically, if you watch anybody's stream, this is pretty much what they're going to use. Either that or something that's a fork of this project. OBS is great. It was fairly easy to set up. It's not as easy, though, as opening up Zoom, hitting Start Meeting, and and recording it to your computer. That's even easier. So do that if you prefer. But again, OBS is a very good tool for this kind of stuff. Okay. Any other questions? Any questions about the final project as it stands? Okay. Other common questions I get, how many, does everybody need to turn it in? I mean, no, what you should ideally do, only one person needs to turn it in. To ensure you all get credit, I would at the very least, if you're not the person turning it in, upload something that says, hey, check out this person, they're the person who turned it in, right? Or, or the GitHub. And again, if you're turning it in, please mention, who was in your project. This is a fixable issue if basically this information is missed. This is easily fixable, but we just, want to try to avoid scaring any of your fellow students with a 0. Oh, they didn't turn it in, I guess it's a 0. No, you just missed it. So, now the plan so our exam is on not next week. Our final exam is not next week, but the week after. It's on the last day of finals, right? So what we are going to do, so my goal is during that rest day, that day where basically it's a study day. So Monday you turn it in. Tuesday, my intent is to basically spend the entire day going through the final project, okay? Going through all the final projects and selecting the ones I think are the best. Okay. Now, the way you'll be notified by an email. About basically everybody in the final with who does the best will be notified by email, most likely very late that night, via a blind carbon copy. So basically same email sent to everybody, but not everybody knows it. Feel free to share your projects, by the way, on Discord as well, to show off what you did. But you'll get an email saying that you're exempt from the final project. I will also then follow that up with an announcement saying that the projects have been selected, so if you've been waiting with bated breath, then you can stop waiting, I guess. But those people will be exempt, will get their final exam marked excused, meaning they don't have to take a final exam. Which is, a fairly good incentive. Now, but yeah, that's essentially how that process works. All right, so what we have planned for the day is that I do have a extra credit quiz, a post-knowledge quiz set up that I plan on giving out later, as well as giving you time to do a survey in class. So I plan on doing that a bit later in the class. But the other thing is that I figured it's probably a good time to start prepping for the final exam. It's looking like, and I will send out more information about this with the final exam. It is looking like a 7 question choose 5. If I come up with an 8th question, it will be 8 questions, choose 5. But the point being is that it will be 5, is that for your final exam, it will essentially be 5 questions, 20 points apiece. You pick the ones you do. If you decide to do more than the 5, I will just simply grade the first 5 I see. That gets away around any kind of issue of misinterpretation there. It allows me to be consistent. So yeah, and it just removes any headaches. Once again, you have to be present for the exam in here, and yeah. So I went looking yesterday, and it did turn out that, hey, I did have some practice problems. So let me go ahead and let's see. So why is that recommended showing up? That should not be showing up anymore. Seriously? Hold on a second. Show more options. Okay, hold on. I gotta fix this because I do not like it when... Yep, clear. Apply. I don't want... There we go. Now, I don't... With so many students I have to advise, I don't like students' private documents coming up on my home folder when I'm trying to broadcast. That's the issue. Okay. So let's go to Documents. Let's go to GitHub. Let's go to Teaching, Intro, and then let's see. So now I'm going to pause. I have, and I will send those practice problems to you. I do have a giant document here called practice problems, a few of them. Make username, let's see, I'll go through these. Make username, XOR, sum of threes. A lot of these did appear on final exams, by the way, as kind of shorter questions when it was on paper, which is probably the format I'm going to do next semester. So you guys get to do it on computer still, but I'll probably transition back to paper next semester. Just seems easier. Okay, so a lot of these are good problems that I've had, especially this problem over here, which we'll get to. We've already done this problem, the head, tail, heads, and the monopoly problem. We've done that one. This one was a Monte Carlo problem that I did a number of years ago, maybe 2 years ago at this point, and it is one that was given on a final exam. It was probably more difficult than in terms of rules, but hey, it was a matter of figuring out the rules and writing it. Although it was easy for people who know Dungeons and Dragons, so I guess. All right, so let's go ahead and get into that. So, okay, what we're going to do over here is we are going to start off with this practice problem. This first practice problem is let's see. Oh, yeah, I already have a final review. Here we go. Yep, and that was one that I need to replace. That was another problem with from the semester. Write a function called makeUsername that generates a username for a given name and suffix, demonstrated by the examples below. You can assume the name of the format of the name is either first name, last name, or first name, middle name, last name. So we're generating a username based off of two arguments, a name and a number. So if you pass in Andrew Rosen 12, you'll get AR12. If you pass in Alan Turing 5, you'll get AT5. Andrew Benjamin Rosen will be and 3 will become ABR3, and Andrew Benjamin Rosen 104 will become ABR 104. For pretty much every problem I try with that have this kind of input out from pretty much every problem but the Monte Carlo, I give you these like example inputs and outputs, right? So over here we've got this make username function. All right. So let's see. I'll warm us up with this one, and then for the other ones, I will give us some time to work on them. Okay. Def username. So this one takes in a username and a number. Let's go ahead and copy over also these bits. You definitely want to, at this point, definitely know your way around your keyboard shortcuts to remember how to copy paste, how to switch between windows very easily, and those kind of things. Just simply speed up your workflow. So make username and name and n. So what we need to do over here is establish, okay, I need to get the first letters of each of these parts of the name, okay? And each name will have two parts, right? And so I got to get the first letter of each of each of these parts. So what do I have to do to this string in order to get the individual names, the individual parts? What operation needs to be performed on this string? Yeah, split, exactly. We want to separate this out. We want to split it. Oh, right, the split command. So let's go ahead and take this name and we're going to split it. So the parts of the name is equal to our name dot split. Okay, we're going to take the name, we're going to split it up. Awesome. Now, This part, not so bad to split it up. The next part is that we need to gather the first letter of each part. If it has 2, we would just simply say, and you might be tempted to do this as kind of your first thing, okay, which is parts, 0, and then get the first letter. You might do something like this. Part 0, 0 is equal to, there's a lot of ways to do this. I do not suggest it doing this way. B is equal to parts 0, 1, but then, not 0, 0, but the first string, 0, the first string and the second character, you can do it like this, by the way. Right? Again, I try to avoid two-dimensional stuff whenever I can, but it is a good tool to know how to iterate through that. Okay? So, now the final part is, wait a second, if I've got 2 parts here, and I do this, if I just pass in Andrew Rosen, and I do this, I'm trying to get the first letter of the second string, of the string at index 2, which would be Rosen, in this case. But if I pass in Andrew Rosen, not Andrew Benjamin Rosen, it will be, okay, this is the first letter, this is the first letter, uh-oh, I got nothing. So that would be out of bounds. So we need to act differently based off of whether or not there's any parts there, how many parts there are. So let's go and do something a bit simpler. Well, bits and easier to read, I should say. If len of parts is equal to 2. So if there's 2 parts for the name, do one thing. Pass. Else, do something else. Okay? And let's go ahead and work on, and what we're going to do is we're going to take these parts and these letters and put them into, and we're going to accumulate them, add them up together, concatenate them. So let's go ahead and make an accumulator. We'll make our answer. Username is this, is equal to an empty string. And we'll take the letters as we go through and we'll add them to that empty string. And then when we're all done with the problem, we'll return our username. So, okay, length of 2 is equal to, all right, so we've got 2 parts. In that case, we would probably want to get, again, we could do something like this. Username is equal to parts, 0, part 0, and then get the first letter of the first string, right? The first index over here is for the word, the second index is for the letter, first letter of the second string, first letter of the third string, right? We could, well, not there, but we could do it like that. But again, it looks not great. I would rather do something like this. First name is equal to parts 0. Last name is equal to parts 1. Readability is king, remember. Being able to read something better makes it easier to understand. Okay? So we now taken that string and we've split it up into its respective parts. And we can say username plus equals the first letter of the first name plus the first letter of the last name. Everybody see how that's equivalent to what I was writing before, which was parts 0, 0, or how I was doing that? Everybody see how last name basically just kind of slips in here, right, and replaces that to make it a lot more readable. Otherwise, copy this, paste it, and what we'll do is that we'll change this up because it's first name, middle name, last name. And then there we go. And now the last part is that we have to attach that number to the end, which happens regardless. Now there's multiple approaches to doing this problem. I just wanted to warm us up with this one, but I'm going to give you the chance to work on the other ones kind of by yourself. Okay? First name, middle name, 0 string, and last name. And now to add the user number plus the string. And there was one other thing, which is that if we try this now on this, right? So I will go ahead and print make username, or if I pass this in, always test your code. Really, I'm having such trouble hitting the right keys today for some reason. Okay, print, make username. Oh, right, sorry. That being able to do print without the parentheses was a thing you used to be able to do in old Python, Python 2. They changed that to make it more consistent. Here it's ABR 104, but it's all caps. Now at the end of the day, this is a very minor thing, but let's go ahead and try to match our output. To make something lowercase, let's just go ahead and take the name and set it equal to name dot, let's see, is it name dot to lower, or is it lower? I think it's lower in Python. Again, it's always a different thing in each language. Yeah, lower in Python to make it all lowercase. Like I said, I have to jump between multiple programming languages. It's okay if you have to look it up or you have to guess sometimes. All right? Now, all right. Now, this next question I think is very fun because it's something that we're kind of adding in at the very last minute. One that you may have heard of, but, oh, and yes. Just worth mentioning, though, that you can assume the format of name is either first name, last name, or first name, middle name, last name. I have a footnote here. It's not true for all cases in real life. And this is it's gone now. But you can look for the page for the title, which is Falsehoods Programmers Believe About Names, which is basically all the things that you believe about names, that you were sure you knew about names, that are absolutely false. Absolutely 100% false. Names are weird and complicated. The amount of times my wife's name has given the issues to online systems is hilarious. My wife's name is Annie Ray. Annie hyphen Ray, no middle name. Not a very complex name, but that hyphen throws most systems through the loop. So you'd be surprised. All right, so next. XOR, XOR. True. So XOR, so we learned about and, we learned about or, right? And it's true if only both are true, and false otherwise. Or is if one thing is true, if either one is true or both are true, then the whole thing's true. It's only false if both are false. XOR, on the other hand, is the OR that we use conversationally. XOR is the exclusive OR. Only one thing can be true. Do you want to go to the movies or do you want to go to the park? Do you want to stay up tonight or do you want to go to sleep? You can't do both. So XOR will take in a true and false, it takes in Boolean statements. Return true if only A is true or only B is true, but false if they're both true or both false. Make sense to everybody? All right, so go ahead and take a few minutes to work on this one on your own. It's a logic puzzle, kind of. And there's about 1.5 million solutions to this one. Some are very quick, some are basically, are short, and some are long, and that's okay, so long as it's correct. Okay, so I will pause. And if you didn't bring a computer today, if you have paper, try it out on some paper or something. Just work your way through the problem. Try to code it out. Pause. A truth table, we're going to be just, effectively doing that with this technique. So our first way of doing this is we are going to go through and write all 4 possible combinations of true or false values. Okay? Def XOR A, comma, B. Okay, there's 4 different ways we can do this. If A equals true and B equals true, and now we realize, wait a second, as I'm doing this, I can, so if they're both true, then I only return true if one is true, only if one is true, right? If they're both true, I'd have to return false. And now you realize, wait, this is actually a bad technique because this is copy-pastable, very copy-pastable, right? So that's what I'll do. It's the nice thing about doing it. Just simply going forward and trying it, knowing that this is a correct way to do it, even though you know it's not the most elegant way. So true, if they're both false, why don't we go through and just write out our possible combinations first. A is true, B is false, A is false, B is true, right? And then false and false, right? Those are all 4 possible combinations. There cannot be any more, right? You can, double check, but there's not any going to be any more. It's not a bad idea to double check on a test. This question was worth 10 points. And now you go to yourself, okay, before I change the returns values to what they need to be, is there any chance of me triggering more than one of these if statements? No, because they all have a return value in them. So as long as it hits one of these statements, we're done. I don't have to elif them. Okay, so if true and true, if they're both true, return true. So if they're both true, return false, because that's what XOR is. Same over here. If they're both false, return false. Done. Now, if only one is true, that's where we return true, right? Everybody see that? This is a working answer. Just sometimes, my friend who's a Google engineer these days gets paid ridiculous amounts of money to work for Google, can't even tell me what he's doing. He had a saying that brute force always works, and it does. Basically, just simply brute forcing your way through the problem, making sure you get to an answer, even if it's not elegant, always produces an answer. A lot of us are caught up in the correct way to do something. The only correct way to do things at this level is whether it works or not. We leave elegance and runtime for later. But let's go ahead and cut this down a bit, okay? Let's go ahead and trim this down, okay? A is true. We can simplify this. If A and B, because if A is true, B equals true, well, if this is true, this condenses to true. And if it's false, it condenses to false. So we can write it like this. If A and B, if A and not B, if not A and B, and not A and not B. Okay? Now, let's go ahead and look at these two things a bit more. How can we condense it down further? When are we returning false? We're returning false when A and B are the same, right? When they're both true or they're both false. We're returning true when they're both the same. So we can simplify that even further by doing this. If A is equal to B, return false. Okay? And if that is two statements condensed into here, and they both have the false statement, and these both statements are true over here, we can simplify that even further. Let's return true, which we can then condense into one ridiculously short statement, which is return A not equal to B. If they aren't equal, return true. So you can trim this down, but you want to know something? No, they all get the equal amount of full credit. So, you know, again, I would rather get you something on an exam. Don't worry about elegance. Worry about getting the answer down on the paper, the electronic paper, so to speak. Okay. This is definitely the kind of problem that will appear on a final exam, guaranteed. Something like Zor, probably not. I find that a great kind of get the gears going exercise. This one definitely will be on the exam. Something like this. Basically the same question, just with the serial numbers filed off, so to speak. Sum of threes. Given a list that contains many lists of integers, return the sum of all the integers in the lists that are multiples of threes. Half credit is given if the answer works on a list of integers. So if you decide, I can't do list of lists, but I know how to do this problem with just a single list, great. There's a way to get half credit here. But for this problem, let's look at how we want to do this. So this top example has one list. Has one list in the list. And the answer is 18. Why? Because 3 plus 6 plus 9, 3 plus 6 is 9, plus 9 plus 9 is 18, so there you go. Here we have a list of 2 elements, a list of 1 element, and a list of 5 elements. This returned 15 because out of all these, there was only one number that was divisible by 3, and that was 15. Same deal over here where we've got 10, 20, 51, 10, 20, 30. We had only one number here that was divisible by 3, that was 30. So the point of these examples is also to show you that you can't expect, you have no idea how many lists inside the list there are, and they're not all going to be the same length. In other programming languages, we might call this a jagged array, which are the worst. In Python, they're just lists of lists, and Python doesn't care. Okay, this is the next question I want you to work on, which is, given a list that contains many lists of integers, so you're guaranteed to know that these are all integers, right? Return a sum of all the integers in the list that are multiples of 3. So I called this one sum of threes. So I ask something like this one all the time. All the time. I ask something like this, but with strings on exam 2, you know. I asked something like this, I know on the past few exams, but with the number divisible by 10 or something like that. I've asked things like this where basically I've said, go through and replace all the numbers that are divisible, with 0, or give me all the numbers that are not divisible by 10. Basically, I do something like this a whole lot. So it's definitely worth, making sure you practice problems like this on whatever kind of iteration. You've been doing school your whole life. You're probably good at figuring out variations of problems at this point. And I'm telling you that there's going to be a variation of this one on the exam, So, sum of threes, numbers. Okay. Triple quote, so I can just grab these because I didn't bother commenting these in for some reason. And there we go. We'll go ahead and create an error right now, but that's okay. And just simply grab this and print. And it's giving me an error because I've got a declared indentation that I haven't written yet. So which is here in the sum of 3's. So total is equal to 0. So I said to start out with this. Total is equal to 0. Return total. Excellent. Okay. Now, you can always decide to change the names of these variables or functions if you don't like them. You could call this super list if you wanted to, or list of lists. But again, variable names help you get into the swing of things. So here I'm going to say for each inner list in the list of numbers, for each of the inner lists, I need to go through them. Okay? And then for each number n in the inner list. Or maybe I could call it for each number, but again, some people don't like me it can be a bit hard to read sometimes if I do it like this. Or I personally do this all the time in my code where I do plural and singulars, but that drives some people nuts because that relies off of a difference of one letter. So yeah, for n in inner list, we need to go through each of those n's. If n divided by 3 has a remainder of 0, if n mod 3 equals 0, return, well, not return, that's actually a common mistake there. But what do? We add to the total. Total plus equals n. So for each number we find that's divisible by 3, we add it to our total. 18 over there. I'm going to go ahead and take this problem over here. So 15 over here. Let's go ahead and change this 20 over here to a 21, this 5 into a 6, and now see how that works. And that came out to a nice, good 42, which, let's see, 21 over here, 6 plus 15 is 21, 21 plus 21 is 42. Math is easy when you already know the answer in advance. So there we go. I changed the input a bit, right? If that went by you super quick. So we'll do one more, and then I'm going to give you time to do the extra credit quiz and the survey before the class ends. Okay. Let's see. We'll skip this one since oh no, we won't skip this one. That one's a good one. All right. All digits product. Given a list of numbers, return the product of all the digits of all the numbers in the list. So here, 1, 2, 3, 4, 5 returns 120. It's returning 5 factorial, in other words. Why? 1 times 2 times 3 times 4 times 5. It's multiplying them all together. All right. 10, 20, 5. So notice that we're not multiplying 10 times 20 times 5. We're multiplying 1 times 0 times 2 times 0 times 5. Right? We're multiplying all the digits together. We've got zeros for digits, so the entire answer is 0. So here we've got 4412 and 3112, which would normally be a nightmare to multiply, but here we're just multiplying the single digits together. 4 times 4 is 16, times 1 is 16, times 2 is 32, 32 times 3 is 96, yes, times 1, right? So that's going to be 96 again. And 96 times 2, that's going to give me 180 plus 18, which gives me 192. All those tricks in mathematics come in handy, being able to break things apart like that. So all digits product. So here, this one I think is a last good one to do for our last problem before we continue. And I'll be going over more this upcoming Thursday lecture. I plan on compiling the practice problems I have and then sending them out. Okay. Okay, and pause. So just in case people are having trouble starting on that one, boom, boom, total is equal to 1 because it's a running product. Return total. That's one of those ones that where where you forget that, you'll have, wonder about it for 5 minutes, why it's not working, and think it's something else wrong with your code. Go ahead and go over this problem. So with this one, let's go. We know the first step, which is for each number in nums. So for each of those numbers, what do we need to do? We need to get all the digits from them. So there's two ways to go about this. The proper efficient way, which is to use a while loop and use modular arithmetic and division. And then, of course, there's the way that you're probably going to do on an exam, which is like, I want another for loop so I can iterate through this, so I'm going to convert it into a string and then convert those strings back into integers. Not efficient, but boy, does it work. Digits is equal to string number. For digit in digits, digit is equal to int digit. Okay, the more I repeat that word, the weirder it gets, and the more I look at it, the weirder the spelling looks. Okay, so, and now total plus equals, not total plus equals, but totals times equals the digit, right? All digits product. That's it for just doing it the, quick and dirty way, where I just simply turned it into a string and then let the string handle everything. So here, 192, no problem there, right? For every number, what I did is I converted it into a string, stored that in a variable, then because it's now a string, I can iterate over it. And for each of those, I can grab, and now since I'm iterating over each of those individual characters, I can turn each of those characters into a number and do the multiplication there. No problem. But the way that you might have to do it in other programming languages is something along the lines of this. While number is greater than 0, digit is equal to number mod 10 to get the last digit. Number divide number is equal to number divide 10. So get the last digit, throw away the last digit, multiply. And that's the other way to do it. The way to do it mathematically. Yes? They are. They're not strings. I mean, I iterated over each of these numbers, 1, 2, 3, 4, 5, but then I had to go through, for each number, I had to multiply the individual digits together. So that's why, let me copy this before I completely undo it. So I'm copy pasting this, right? So the reason you have to do it either one of these two ways, is that we get the numbers, but then we have to multiply the individual digits in the numbers together. We're not multiplying the numbers together. We're not multiplying 44, 12, 31, 12. We're multiplying 4, 4, 1, 2, 3, 1, 1, 2. So in order to iterate through that, we needed to multiply those digits together by getting each individual digit. All right. So let me go ahead and stop recording. We'll pick up